Question 1 from the 2023 Advanced Higher Physics Examination from the SQA. A hot air balloon accelerates vertically upwards from the ground. During the first 8 seconds of flight, the vertical velocity v of the balloon is given by the relationship v equals 0.0044 t cubed, add on 0.012 t squared, where v is measured in meters per second and t is measured in seconds. Now, using calculus methods, we're asked for 3 marks to determine the vertical acceleration of the balloon at a time t equal to 8 seconds. Well, first of all, we know that the velocity equation, a relationship given, is the one stated, 0.0044 t cubed plus 0.012 t squared. So how do we get acceleration from that? Well, we know that acceleration is the rate of change of the velocity. In calculus terms, acceleration is dv by dt. So all we have to do is find the derivative of the function v, and we do that as following. We can say that the acceleration is going to equal to, we multiply by the power of 3 times 0.0044, and we take 1 off the power of 3 to give us t squared. And we do the same with the next expression, plus we multiply by the 2 and take 1 off the power. And we're left with that expression there, that equation. So a equals 3 times 0.0044 t squared plus 2 times 0.012 t. And all we have to do is put in a little simplification, multiply the 3 through there, and we get 3 times 0.0044 gives us 0.0132 t squared, plus, and we multiply by the 2 to give us 0.024 times t. So that's now us got the function for the acceleration, if you think of it in maths terms. And all we have to do is put in the value of t being equal to 8 seconds. So at that particular point, at 8 seconds, we can just down here, at 8 seconds we have got 0.0132 times 8 squared plus 0.024 times 8. And when we do our calculation, we find out we get the following value. We get the acceleration at time 8 seconds is equal to 1.037 meters per second every second. Question 1, part B. It says determine the vertical displacement of the balloon at t equal to 8 seconds. Once again, we've got to do it by calculus methods, and we know first of all that the velocity is going to be equal to the rate of change of the displacement. So in terms of calculus, v equals ds by dt. Now we do a little bit of cross multiplying here. We get the following. We get ds is going to equal to v dt. And now in a position to integrate both sides. So we integrate both sides, we get that expression there. ds, integration of ds, is going to give us the total displacement s, and that's going to be the integral of v dt. So all we have to do is stick to our calculus methods, the same way we do in higher maths. The displacement s is equal to the integral from 0 up to 8 of the function of the velocity v, which is that expression there, the 0.0044 t cubed plus 0.012 t squared. Put a big bracket around that, and it's going to be integrated with respect to t. So we do that and put in our limits, we get the following. We get s is going to equal to 0.0044, and in this case you add on 1 to the power and divide by the new power, so you're going to have t to the power 4 divided by 4, plus you add on 1 to the power, it becomes t cubed, and you divide by 3 to give you that expression there. So we simplify that out, we get the following. We get s is going to equal to, and we put in our limits, we put in 8 for the upper limit of the time, and as you can see we put in the lower limit t equal to 0, because we'll get t to the power 4 and t to the power cubed in the expression, then we're going to get the 0 limit of time going to be equal to 0. So all we have to do is do a simple little calculation with a calculator, 0.0011 times 8 to the power 4, keep it in brackets to keep your working safe in the calculator, plus bracket 0.004 times 8 cubed, and if we get our answer to that, we should get our final answer for the total displacement at that time, and we get 6.55 meters.